Problem number 52, page 632, equilibrium section of the text. In this problem, we're given a balanced chemical equation. We're told that the equilibrium constant for the reaction is 1.0 times 10 to the second, same as 100. We are given initial concentrations. We're told that the hydrogen gas, iodine gas, and HI gas all are comprised of 1 mole in a 1 liter container. Therefore, the molarity for each of the gases initially is 1 molar. We need to calculate the concentrations of all chemical species when equilibrium is reached. To solve this problem, we're going to need to set up an ICE box. ICE. I stands for initial concentration, C, change in concentration, and E, equilibrium concentration. This ICE box has been completed. To write an ICE box, you need to have a balanced chemical equation, which we do. I stands for initial concentration. So I've put in the initial concentrations of the I2 gas, the H2 gas, and the HI gas. The change in concentration corresponds with the stoichiometric coefficients and if the chemical species is a reactant or a product. If the chemical is a reactant, the change is represented with a negative sign, and if the chemical species is a product, the change is represented with a positive. Negative indicating the change, the chemical is being used. Positive, the chemical is being produced. The magnitude of the change corresponds with the stoichiometric coefficient from the balanced chemical equation. Here we have 1H2, so the change is negative 1x. 1I2, the change is negative 1x. 2HI, so the change is positive 2x. The equilibrium concentration is a combination of the initial concentration and the change. So 1 minus x, equilibrium concentration 1 minus x. Same here. Here the equilibrium concentration for HI is 1 plus 2x. Since we need to find the concentrations at equilibrium for this problem, I've rewritten the equilibrium concentrations we just determined from our icebox. I've written the equilibrium constant expression because to solve the equilibrium concentrations, I'm going to use the equilibrium expression to help me do that. Substituting the values that were given and what we determined into the equilibrium concentration. We were told that the equilibrium constant was 100 for this reaction. We've determined using our icebox the equilibrium concentrations for each of the chemical species. I've substituted those and created this expression now. Now, to determine the equilibrium concentrations of each of the chemical species, I need to figure out what is X. If I can figure out what X is, then I'll be able to determine the concentration of each of the chemicals at equilibrium. Using this equilibrium expression, where we have substituted in the equilibrium constant and the equilibrium concentrations, I can solve this for X, substitute X into each of these concentrations, and then determine the equilibrium concentration. Starting on the top left here, this is the expression after substituting in the values given and determined in the problem. So first thing I'm going to do is combine the denominator here. 1 minus x times 1 minus x is 1 minus x squared. What I've noticed is if I take the square root of 100 in the square root of this side of the equation, I'm going to get the square root of 100 is 10. The square root of 1 plus 2x squared is 1 plus 2x. The square root of 1 minus x squared is 1 minus x. Then, this is much easier to solve algebraically. As you can see, you should be able to determine that x is equal to 0.75. Now that we determined x to be 0.75, all we need to do is substitute this value in to the equilibrium constant, or excuse me, to the equilibrium concentrations here. Then we'll figure out the equilibrium concentration. So here, substituting 0.75 for x, calculating. You'll then determine that the equilibrium concentration of H2 is 0.25 molar, the equilibrium concentration of I2 is 0.25 molar, and the equilibrium concentration of HI is 2.5 molar. Questions?